New
Targeted drug
podcast by
delivery.
Mohammed
Yes,
Abdullah.
absolutely. AI is the
Nanomaterials,
key
Science
factor
and
in optimizing the
Technology.
design of these drug carriers. The most common ones are lipid nanoparticles.
Which are?
They're basically tiny bubbles of fat. They're designed to wrap up a drug and carry it safely through the bloodstream. If you want a reference point, they're the standard carriers used in modern mRNA vaccines.
Okay, I see.
So the AI simulates how all these different nanoparticle designs will interact with the body, how they get through blood vessels, how they avoid the immune system, and crucially, how they attach to this specific target, like a tumor cell.
So it's maximizing the good stuff and minimizing the bad.
It's precision medicine built from the blueprint up. You get more of the drug to the tumor and less of it floating around causing side effects.
And what about outside the body? We hear about these self-repairing adaptive materials. AI is essentially creating inorganic materials that have almost biological capabilities. So materials designed to sense damage, a tiny crack, and automatically trigger a repair
The crack just fills itself in.
moments. Or, even more compelling, you have adaptive coatings. AI helps engineer these nanofilms to change their physical properties like texture or color or even reflectivity in real time.
So you could coat an airplane, for instance, and the material could change its texture to reduce drag.
Exactly. An onboard AI could analyze airflow and temperature and tell the material to microscopically change its surface. The fuel efficiency gains would be dramatic. We're moving toward materials that are active participants, not just passive shields.
Incredible. So AI is designing this perfect, almost sentient matter. Now let's flip the equation, because that matter is needed to fuel the AI itself. Part 2, nanomaterials as the future of AI hardware.
This is where we hit a physical roadblock. AI models are getting smarter, exponentially so, but our traditional silicon chips, they're hitting their physical limits.
You're talking about the von Neumann bottleneck.
Yes. Can I define that quickly?
Please.
In traditional computer architecture, memory and processing are physically separate. Your processor and your RAM. Data has to constantly travel back and forth between them.
Which wastes time and energy.
Massive amounts of time and energy. It's like having to leave your desk and run to the library every single time you need to look up one fact. To push AI further, we need computing to happen right where the data lives.
And that brings us to neuromorphic computing. Mimicking the human brain to get around that problem.
It's the highest goal right now. To build these brain-like chips, researchers are using specific 2D nanomaterials. Graphene is the famous one, but also things like MXenes and transition metal dicoltigenides.
And what's special about them?
They're atomically thin, so they have unique electronic properties and a huge surface area that silicon just can't compete with. This lets you pack in an unbelievable density of artificial synapses.
And the building block for those is the memory store.